Somewhere in the Arizona desert, more than 4,000 commercial airplanes sit parked in perfectly straight rows, wingtip to wingtip, stretching for miles under the sun. Some have been sitting there for decades. None of them will ever fly a passenger again, and yet almost nothing about them goes to waste. Aircraft boneyards cluster almost exclusively in the American Southwest, in places like Pinal Air Park in Arizona, Mojave Air and Spaceport in California, and Davis-Monthan Air Force Base near Tucson. The reason is climate, not convenience. Low humidity and minimal rainfall dramatically slow corrosion on aluminum airframes, and the hard-packed desert soil is solid enough to park a 400,000-pound aircraft on without ever needing to pour concrete. A jet parked in a humid coastal climate would start rusting and degrading within months. In the dry Sonoran Desert, the same airplane can sit intact for 20 or 30 years. Pinal Air Park alone can hold several hundred aircraft at a time. And at its peak, the combined boneyards of the American Southwest have stored well over 4,000 retired airliners and military aircraft simultaneously. The facilities themselves are often former military airfields or lightly used regional airports, chosen decades ago specifically because they had long runways, wide open land, and almost no nearby humidity to worry about. It is a common misconception that boneyard aircraft are broken or unsafe. Most retirements have nothing to do with mechanical failure. Airlines retire aircraft when they become less fuel efficient than newer models, when maintenance costs start climbing as the airframe ages, or when a fleet-wide model gets phased out in favor of a more modern replacement. Sometimes it is simpler than that. During the pandemic, airlines temporarily parked hundreds of wide-body jets almost overnight because there was nowhere else to put a plane nobody needed to fly. A 20-year-old aircraft can be entirely airworthy and still make more financial sense parked in the desert than flying a route that no longer turns a profit. There is also a purely financial calculation behind the timing of most retirements. Airlines typically plan an aircraft's economic life around 20 to 25 years, not because the airframe wears out structurally, but because scheduled heavy maintenance checks become dramatically more expensive as an aircraft ages, and newer aircraft burn 15 to 20% less fuel doing the same job. At some point, the math simply stops working. Continuing to operate an older jet costs more in fuel and maintenance than leasing or buying a newer one, even after factoring in the cost of the new aircraft itself. Flyable storage is more involved than it sounds. Maintenance crews start the engines and cycle the flight controls on a regular schedule, sometimes monthly, to keep seals lubricated and prevent components from seizing in place. Landing gear gets extended and retracted, hydraulic systems are pressurized and checked, and the aircraft's logbooks are kept meticulously current so that its airworthiness certificate never technically lapses. This matters enormously to leasing companies, which own a significant share of the world's commercial aircraft fleet. When a leasing company has an aircraft in flyable storage and a new airline customer needs capacity quickly, reactivating that airframe can take a matter of weeks, compared to the years-long waitlist for a brand new aircraft straight from Boeing or Airbus. During the early stages of the pandemic, this is exactly what happened in reverse. Airlines rushed hundreds of jets into storage almost overnight, and as travel demand recovered, many of those same aircraft were pulled back into flyable storage status and quietly returned to active schedules. An aircraft does not just get parked and abandoned. It goes through a formal preservation process the moment it lands for the last time. Ground crews drain every drop of fuel, hydraulic fluid, and engine oil, since standing fluids left inside an idle aircraft accelerate corrosion and can damage seals over time. Every opening from the engine intakes to the cockpit windows gets wrapped in reflective white tape or fitted covers to block sunlight and keep dust, insects, and small animals from getting inside. Technicians place desiccant bags, moisture-absorbing packets, throughout the cabin and cargo holds to keep humidity as close to zero as possible. And the whole airframe gets coated in a corrosion-inhibiting compound before it is towed to its final resting spot in the row. Not every aircraft in a boneyard is destined for the scrapper. Some are kept in what is called flyable storage, maintained just enough that they could theoretically return to service if a leasing company finds a buyer or an airline's fleet needs suddenly change. These aircraft get periodic engine runs and inspections to keep their airworthiness certificates from lapsing entirely. Other aircraft are stored in a lower maintenance state purely to preserve resale value on individual components, with no real intention of ever flying the airframe again. And a third category is scheduled for full teardown from the moment it arrives, usually because the model is old enough or damaged enough that no one expects to reuse the airframe itself. Interior teardown happens in parallel with the structural work. Seats, galley equipment, overhead bins, and even carpeting get removed and sorted, since airline interiors are frequently refurbished and reused on other aircraft rather than scrapped outright. Some retired seats and cabin fixtures even end up resold to private buyers and aviation enthusiasts. an entire secondary market that exists almost entirely because of Boneyard teardown work. When an aircraft is marked for scrapping, specialists work through it almost like a surgical procedure rather than a demolition. The engines come off first, since they are by far the most valuable component on the entire airplane and are frequently worth more individually than the rest of the aircraft combined. After that, technicians remove landing gear, avionics, flight control surfaces, cockpit instruments, the auxiliary power unit, and even the black box recorders, all of which get refurbished, certified, and sold back into the parts market for other aircraft of the same type still flying today. Only after every reusable part has been harvested does the stripped airframe itself get cut apart, usually with guillotine shears or torches, for raw scrap metal. Not every aircraft that enters a boneyard leaves as scrap metal, and some of the most famous examples never flew again for very different reasons. When the Concorde fleet was retired in 2003, most of the surviving airframes went not to a scrapper but to museums around the world, preserved intact as a reminder of supersonic commercial travel rather than harvested for parts. On the other end of the spectrum, entire fleets of aircraft have occasionally been scrapped almost immediately after retirement when a manufacturer discontinued spare parts production, making long-term storage pointless since there would be no way to keep them airworthy even if an airline wanted them back. Boneyards have also occasionally become unlikely filming locations and even backup storm shelters for smaller aircraft during hurricane season, since a facility built to withstand decades of desert sun is also remarkably good at surviving whatever weather occasionally does roll through. A retired Boeing 747 contains roughly 6 million individual parts, over 170 miles of internal wiring, and close to 150,000 pounds of aluminum. Once the reusable parts are pulled, what remains still has serious commodity value. Aluminum, titanium, copper, and stainless steel all get separated and sold into global metal markets, and a single wide-body airframe can yield well over 100 tons of recoverable metal. This is why boneyard operators are picky about which aircraft they accept and how they process them. A single well-preserved airframe can generate revenue for years, first through parts sales, and only at the very end through scrap metal, long after the plane last carried a passenger. This constant harvesting of retired aircraft is exactly what keeps thousands of older planes airworthy today. Airlines flying aircraft that are no longer in production, or nearing the end of their production run, rely heavily on what the industry calls the used serviceable material market, essentially a global second-hand parts supply chain built almost entirely on boneyard teardown. A specific instrument, hydraulic pump, or avionics unit pulled from a retired jet can be recertified and installed on a currently flying aircraft of the same type for a fraction of the cost of a brand new replacement part, assuming the manufacturer even still makes it. Without boneyards feeding this market, maintaining older aircraft fleets would be dramatically more expensive, and in some cases nearly impossible. Aircraft recycling has become a serious environmental consideration in its own right, not just an afterthought to the parts business. A commercial airliner contains dramatically more recoverable aluminum per pound than almost any other retired vehicle, and recycled aircraft-grade aluminum requires roughly 95% less energy to reprocess than mining and refining new aluminum from raw bauxite ore. Several specialized aircraft recycling companies now advertise diversion rates above 90%, meaning the overwhelming majority of a retired airplane's mass, by weight, gets reused as parts or recycled as raw material rather than sent to a landfill. As airlines and manufacturers face growing pressure to account for the full life-cycle emissions of their fleets, the boneyard and recycling industry has increasingly positioned itself as a legitimate part of aviation's broader sustainability story, not just a graveyard for old machines. None of this parts harvesting works without extremely strict documentation, because aviation regulators do not allow a part to simply be pulled off a retired jet and bolted onto a flying one without proof of where it came from. Every component removed during a teardown gets tagged with a traceable history, including which aircraft it was removed from, its total flight hours, and certification records showing it meets airworthiness standards. This process, often called a full traceability package, is what allows a used hydraulic pump or landing gear component to legally return to service on another aircraft. Reclamation companies that specialize in this work essentially function as a licensed chain of custody for aircraft parts, and losing that documentation instantly turns an otherwise valuable component into scrap, since no airline or regulator will accept an untraceable part on a passenger aircraft. Running a boneyard is its own specialized business, and it rewards patience over speed. Storage fees paid by airlines and leasing companies to park an aircraft can run into the thousands of dollars per month per airframe, which on its own can make simply holding onto hundreds of aircraft a steady revenue stream before a single part is ever sold. From there, boneyard operators and reclamation specialists make ongoing decisions about market timing. since the resale value of a specific engine model or avionics package can shift significantly based on how many aircraft of that type are still flying worldwide. An operator holding a rare part in high demand can often wait months or years for the right buyer rather than dump it at a discount. And that patience is exactly what turns a retired airplane from a one-time scrap sale into a slow-burning, multi-year source of revenue. So the next time you see satellite photos of hundreds of airplanes lined up in the desert, know that very few of them are simply rotting away. Some are waiting for a second career in the sky. Others are quietly being taken apart piece by piece to keep the rest of the fleet flying just a little longer.